Hi and welcome to another Mathfolio video. This time we are taking a look at the January 2016 Common Core Regents exam. Let's get started. Okay, part 1, question number 1. Often these Regents start off with very similar questions. This time we are looking at cross sections again. So the question is saying William is drawing pictures of cross sections of a right circular cone below, which cannot, so we're going to circle it because it uses the word not in italics, cannot be a cross section of a cone. Or if we cut it across here, we're going to get a circle right here. If we cut it slanted, we're going to get an oval. If we cut it straight down the middle and open it up, we're going to get a triangle. And if we cut it here, we're going to get almost a semicircle or a semi-oval. So out of all of these, the shape that we cannot get is, in fact, a square. There's no way to cut this and get a square. So question number 1 is answer number 1. Okay, question number 2. An equation of a line perpendicular to the line represented by this equation and passing through this point is, okay, so they give us this equation, y equals -1/2 x minus 5. Now one thing to note is the slope of this is -1/2. Now they want to know the equation of a line perpendicular. Well, if it said a parallel line, that would have the same slope. But it says a perpendicular line, and so it's not the same slope, but it's the negative reciprocal slope. So what we've got to do, we've got to take this 1/2 and turn it upside down, 2/1. Now it's already negative, but we've got to negate it, so it becomes negative, because it's already negative in the first place. So a negative becomes positive, and 2/1 is 2. So the slope of a perpendicular line is going to be just +2. So let me change color for the next bit. We know that the equation of a line looks like y equals mx plus b. Now we already know the slope of this new perpendicular line has to be 2, so we're going to say 2x plus b. And the other thing that we didn't use yet is this, that it goes through this line 6, -4, so we've got to plug this in to the x and also to the y. So make sure we put them in order. It's x comma y. So this is going to be -4, which is our y value, equals 2 times 6 plus b. Now remember, we're just trying to find out the b, and then we've got our equation. We just plug that b back in here and we're all set. So anyways, -4 equals 2 times 6 is 12 plus b. So to get b on its own, we subtract the 12. And in fact, we get b equals -16. So changing the color one more time. If we look right here, we just need to fix this up a little. Y equals 2x plus. Now really we actually could have cancelled out these two options because the 2x only lives in option 3 and 4. But this time plus b, and that's plus -16. So let me fix that a little. Gotta back up. So it's plus b, and b is -16. And when you add -16, you're really subtracting 16. So the best way to write this is y equals 2x minus 16. So number 4 is our answer for question number 2. Okay, this time is number 3. And it says in parallelogram QRST. So I'm going to stop right there. This is a parallelogram, so we know a whole bunch of things. We know opposite sides are parallel and also opposite sides are congruent. We know this must also be parallel, and we also know that Q to R, which is this whole thing here, must be the same as T to S. So I'm going to put 2 lines on this thing. Okay, so that's one thing that we know. We also, well, that's 2 things that we know. We also know that this angle here must be the same as this angle here. And we know the whole of this angle T must be the same as the whole of this. Okay, So let's keep reading. Shown below, TR is drawn. Okay, great. U and V are points on TS. So U and V are points on TS and QR respectively. And UV, U to V, intersects TR at W. So we also know that this here is congruent to this here because they're vertical angles. Alright, switching up the color. So we're told the measurement of angle S is 60 degrees. So I'm going to write that in pink. So if that's 60, we also know this is 60. Next, we know that the measurement of SRT, so S to R to T, so we're dealing with this angle right here. We know this angle is 83 degrees. Now, because TS up at the top, well, TS and QR are parallel, but also SR and QT are parallel. And so TR is pretty much a transversal. So if this is 83, on the alternate interior side, meaning this angle here, this would also be 83 degrees because they're alternate interior. Sometimes they're called Z or Z angles, depending on which part of the world you're in. So SRT 83, great. And also we're told TWU, T to W to U, TWU is 35 degrees. Alright, and that means that this is 35 degrees because they are vertical angles. So finally it asks for what is the measure of angle WVQ. So W to V to Q is right here, and that's what we need to find. So I'm going to call it X, and I'm noticing that X is the part of this shape QVWT, which is a quadrilateral, and we know two angles in this quadrilateral. Now if only we could find out this angle here, then we know that four angles in a quadrilateral, they must all add up to 360 degrees. So let's take a look. If I change this to red and grab a straight line over here, take a look at this. You see that W and the 35 degrees, they make the straight line. So then that means that they are a linear pair. So in fact, what we know is that 180 minus the 35 must give us that angle, that piece W. And so this would give you 145 degrees. So that lives here, 145 degrees. So we have this shape, 1, 2, 3, 4. We know this is 60. We know this is 83. We know this is 145. And this is what we're looking for. We called it X. So if we add them up, 60 plus 83 plus 145 plus X, the sum of all those four angles in a quadrilateral must be 360 degrees. So there's a couple ways we know that, either just by memory, or we can use n-2 times 180, where n is the number of sides, and that gives you the interior sum of angles if we plug in 4. The other way is, visually, if you see it, we can actually split this four-sided shape into two triangles, and each triangle has 180 degrees. Anyways, let's get back to work. So if we add these three numbers up, I'm going to grab a calculator right now. Okay, so I was being a little lazy, but the answer I get is 288. So in fact, this becomes 288 plus X equals 360. So to solve this, if you subtract the 288, what you get is X equals, well, adding 12 to 288 gets us to 300, so it's 12 plus the 60, so it's 72 degrees. So that's X, which really, they ask for the measure of angle WVQ, which is the 72 degrees, and here's our answer right there. So question number 3 is answer number 3. Okay, this time number 4, a fish tank in the shape of a rectangular prism. So I'm going to stop right there, draw my picture. I'm going to draw a rectangular prism by doing two rectangles just slightly askew from each other. So at this point, we know it's got dimensions of 14 inches by 16 inches by 10 inches. And it says the tank contains 1680 cubic inches of water. So we know the volume so far, so I'm going to put volume so far because I don't know if it's full, equals the 1680 inches cube or cubic inches. And it says what percent of the fish tank is empty. Alright, so to figure that out, we need to find the volume when it's full. Well, the volume when it's full is LWH, which equals 14 times 16 times 10. So again, I'm going to grab a calculator. 14 times 16 times 10 is going to equal 2240. So volume when full equals 2240 inches cube. So it wants to know how much is empty, or what percent is empty. Well, let's find the percent that is full first. So we're going to do that by doing the 1680 divided by the 2240 and then times by 100. Now we must remember this is the volume when full. So 1680 divided by 2240, and I'm going to press equals on that and then times by 100. So that gives me a volume full of 75%. But hold your horses, we don't want to bubble in number 4 because that's a volume full. So if this thing is 75, now I'm going to call this in a little. If this is 75% full, and they want to know how much is empty, then surely it's the 100% minus how much full it is, 75%. So that gives us our answer of 25%. So 25% is how much empty. And so I would probably should have really circled that word much earlier. So option 2 for question number 4. Okay, so this is question number 5. It says, which transformation would result in the perimeter of a triangle being different to the perimeter of its image? Okay, so we've got to think, what types of transformation do we have? Well, we've got, so let me write this out, transformations. There's 4 different transformations. There's the slide, which the fancy word is translate. There's the turn, rotate or rotation. There's reflect, which is a type of flip. And then there's dilate, which is the one which stretches or shrinks. So it says, which transformation would result in the perimeter of a triangle being different from the perimeter of its image? So if you do any of these 3, they're rigid motions. They keep all the distances the same, so distance is preserved. Another word for rigid motion is isometry. However, in a dilation, this changes the size. So looking at these, this looks like it could have been a reflection over y equals x. This looks like a rotation, and then here we've got a translation. So this one here, because we've multiplied the x and the y by 4, that's your scale factor is 4. So this one is your dilation. So number 3 is the answer, because a dilation does not preserve distance. Okay, question 6. All right, in this question, the diagram below, FE, which is right here, bisects AC at B. So if AC is bisected, that means that this piece and this piece are the same. So far we just handled this. FE is doing the bisecting. FE itself isn't bisected, but FE bisects AC. So it cuts AC in half at B. Next, let me just change the color. It says, and GE, so GE is this other line, bisects BD at C. So BD is being bisected. So it means that this here is the same as this here. Well, if this is the same as this, and this is the same as this, we also know that segment AB is congruent to segment CD. We also know that. So anyways, we're asked, which question is always true? Well, let's take a look. AB and DC, well, that's the same as what I got here. They just switched the letters, which we're allowed to do. So this is always true. And if you go through the others, they start talking about whether FB is congruent to EB and other such things. And in this case, it's not true, because the only things that are being bisected are AC and also BD. So our answer, we found it, is number 1. Okay, question 7. So here we are told that as shown in the diagram below, a pyramid has a square base whose sides measure 6. Well, square base, this must be 6 inches as well. Told that the altitude of the pyramid measures 12 inches. Let's label that. So the altitude goes all the way down to the middle. This is 12, also it's 90 degrees. Let's label that. Its volume in cubic inches is, so it's trying to find the volume. Well, the volume for this shape is 1/3 base area times height. And in this case, the base is a square, so it's 1/3. Now, the area of a square is 6 to the second power times the height, which is 12. So this is going to give us 1/3 times 36 times 12. So 1/3 times 36 gives us 12, then times it by 12. 12 12s are 144. So the volume of this shape is 144 inches cubed, or as they put it, cubic inches. Number 2 is the answer. Okay, question 8. Triangle ABC and triangle DEF are graphed on the set of axes below. Alrighty. Which sequence of transformation maps triangle ABC onto DEF? So we're going from triangle ABC, which I've just labeled number 1, to triangle DEF, which I've labeled 2. So how do we go from here to here? Let's take a look. A reflection over the x-axis followed by a reflection over the y. Well, if we reflect over the x, A, which is 2 away, becomes 2 up. So that's A prime, let's call it. B, which is 3 below, becomes 3 up. B prime. And C, which is 1, 2, 3, 4, 5, 6 below, goes 6 up. That's 3, 4, 5, 6. C prime. So this would go here with the reflection over the x-axis, and then a reflection over the y would mean that C does go to F, that's C prime rather, and A prime goes to D, and B prime goes to E. So the only other thing to check is that the letters are in order. It says ABC onto DEF. So let's take a look. Does A end up on D? A prime to D, yep. Does B end up on E? Yep, it does. And C ends up on F. So which sequence of transformations? We found it. Number 1. That is our answer. It maps triangle ABC onto triangle DEF. Okay, question number 9. In triangle ABC, the complement of angle B is A. Which statement is always true? Well, let's take a look at this. Triangle ABC, I'm just going to throw this down real quick. ABC. It says the complement of B, complement of this angle is this angle. Well, let's think what that means. If we're talking about complements, we're talking about angles that add up to 90 degrees. So if the complement of B is A, it means that A plus B must equal 90 degrees. And if this is true, because a triangle has to have 180 degrees, it means that C itself must also be 90 degrees because there's 180 total. So in fact, I should redraw this triangle to reflect that angle C is 90 degree angle. And so let me put A here, A, B, C. So it says which statement is always true? And then we've got some sins, some causes, and some tans. Well, first of all, let's write out the trig ratio. So, ca, toa. And if we remember, this is sine equals opposite over hypotenuse. Cosine of the angle equals adjacent over hypotenuse. And tan of the angle equals the opposite over the adjacent. Well, one method, there's a couple, one method to figure out which of these are equivalent is to use some letters in this diagram. So opposite big C is little c, opposite big A is little a, and opposite big B is little b. So for number 1, it says tan A. So tan of angle A is toa. So that's the opposite over the adjacent. So that would be A over B equals, now tan B, opposite would be B, adjacent is A, B over A. Now the question said which one is always true. Now this doesn't always have to be true. In fact, most of the time it won't be true unless A and B are congruent. And A and B would be congruent if this was a right isosceles triangle, which is sometimes, but not most of the time. So it is not number 1 because we do not have the same letters in the same place. So let's check number 2. I'm going to change the color. Okay, for number 2, it's a sine of A. So A is over here. Sine, we're dealing with opposite and hypotenuse. So number 2 is A over C equals sine B. So that is opposite over hypotenuse is B over C. And again, this isn't the same bunch of letters in the same order. We've got an A up here and a B there. So these would only be congruent if A and B were the same. And so this would have to be isosceles right again. So number 2 is not the correct answer. Okay, trying another one. Here cos A, so cos of angle A equals the adjacent, which is B, all over the hypotenuse, which is C. And does that equal a tan B? So tan of B equals the opposite over the adjacent TOA. So that's B over A. Nah, that doesn't make sense. That's not going to be true because we don't have the same letters in the same order again. So it must be number 4, but let's just check it. Let me cross out 3. Let's check number 4. So say sine of A, well, A is here, and the sine of A is the opposite over the hypotenuse, so that's A over C. Does it equal cos B? Cos B, so that's what we're checking. Cos of B is the adjacent, because it's ka, adjacent over hypotenuse. So that's A over C. So hopefully now you can see both of these fractions are identical. So this is what's always true. And so number 4 is our answer for question number 9. Okay, this is 10. Okay, a line that passes through the points whose coordinates are 1, 1 and 5, 7 is dilated by a scale factor of 3. So let's think about this. All right, I'm going to, oops, a little crooked. Let me actually use the line tool. I'm going to plot this real briefly. So I'm going to go straight down, use the shift, and then also let me go straight across. So the point that we're given, first of all, is 1, 1. 1, 1, so let's say this is 1, and this is 1. And the next point is 5, 7, so 5 might be over here somewhere, and 7's all the way up here. So this is 5, 7. And it says a line passing through points, these points, 1, 1, is dilated by a scale factor of 3. Well, the line itself might look something like this. Okay, it doesn't necessarily need to go through the origin. Mine's pretty close. But it says that it's dilated by a scale factor of 3 and centered at the origin. So it is dilated by a scale factor of 3 and centered at the origin. Okay, so that doesn't mean this goes through the origin, but it does mean that the dilation is centered at the origin. So everything's stretching away from that point. It says the image of the line will be, and then we've got these 4 options. So let's think what happens when we dilate with a scale factor of 3. It means k equals 3, which means that our x comma y becomes 3x comma 3y. So this point 1, 1 now becomes, I'm going to do this in a different color, 1, 1 becomes 3 times 1, 3 times 1, so 3, 3, and the other point, 3 times 5 is 15, comma 21. These are the new points. So we've got, it's very hard to plot this because I don't have a lot of room, but 3, 3 might be somewhere like here, and then the other one, which is 15, 21 is all the way out here somewhere. So I'm not even going to sketch it right now, but it's somewhere over there. So let's think about it. Does it look like this line is going to be perpendicular? Well, to be perpendicular, it would need to change its slope from positive to negative or negative to positive. So it's definitely not that one. Okay, is the line parallel? Well, it might be. It might be parallel because it does stretch all the way up there. And then also, is the line the original line? Well, and does it pass through the origin? So we've got these three answers right now. So let's think about this. And let's think what happens. Well, if I am to get the equation, let's get the equation of the first line. So the line starts y equals, let me undo this. The first equation is y equals mx plus b. Now, to find the slope, we've got these 2 points. The 2 points are 1, 1 and 5, 7. So the slope is the change in y, so 7 minus 1, all over 5 minus 1. So the slope is 6 over 4, so that slope is 1.5. Now we can put that 1.5 back in, so y equals 1.5x plus b. And while we're at it, let's take one of these points. Let's take 1, 1 and plug in. So 1 equals 1.5 times 1 plus b. So 1.5 times 1 is 1.5. If we subtract that from both sides, minus the 1.5, minus the 1.5, we end up with b equals negative 0.5. So our equation for the first line is y equals m, which in this case we already said is 1.5, x plus b, well b is negative, so it's minus 0.5. That's going to be the equation for the first line. So to find out if it's parallel, it's going to have the same, the new line is going to have the same slope. And to find out if it passes through the origin, this is going to give us a y-intercept, which is the letter b of 0. And to find out if it's the original line, it's going to have the same equation. So this is really covering all bases. So I'm going to switch out the color. Let's find the equation of a new line. So the new line, y equals, I'm going to put mx plus b. So our two new points are 3, 3. So let me put them here, 3, 3 and 15, 21. So the rise is the change in y, which is 21 minus 3 all over 15 minus 3. So this is 18 all over 12, which 18 over 12 divided by 6, we get 3 over 2, which is 1.5 again. So we do have the same slope. So it kind of is parallel. But let's just see if it's the original line. So y equals 1.5 x plus b. Now we've got to use these two new points, or at least one of them, and then plug it in. So let's plug in the 3, 3. So if I put a 3 here, equals 1.5 times 3 plus b. So this gives us 3 equals 4.5 plus b. So minus 4.5 minus the 4.5. So here I end up with b equals negative 1.5. b equals negative 1.5. So our equation of the linear line is y equals 1.5x minus 1.5. So there is a different y-intercept, so it's not passing through the origin, and it's not the original line, but it is parallel. So we did quite a chunk of work there, but we did get to the bottom of it. The answer for number 10 is number 2. Okay, question 11 this time. Okay, quadrilateral ABCD is graphed on the axes below. When ABCD is rotated 90 degrees in a counterclockwise direction about the origin, its image is quadrilateral A prime, B prime, C prime, D prime. So this kind of turns around. Just choose one of the points. It goes 90 degrees counterclockwise. If that point does that, all the other points are going to do the 90 degrees. And the whole shape will turn 90 degrees. Okay, it says, is distance preserved under this rotation? Well, the only transformation when distance isn't preserved is dilation. And so all other transformations are rigid motions. So the first part is distance preserved. The answer is yes. So we're looking here and here. These other two we're going to cross out. So it says which coordinates are correct for the given vertex. So let's see where A would go. I'm going to change this up to red. At the moment A is here. And if we look, A is 1, 2, 3, 4, 5, 6 units up and 2 units to the right. 6 units up and 2 units to the right. So if we're going to go 90 degrees counterclockwise, instead of going up to north, we're now going to go west. We're going to go the same number. So this was 6. So now we're going to go 6. 1, 2, 3, 4, 5, 6. And then instead of 2 to the left, we're now going to go 2 down. So A comes here, A prime, which is -6, -2. So that is not what this says. So this is trying to trick us. Maybe that's the coordinate when it goes clockwise, but it does tell us counter. So it's not this. So 4 must be our answer, but let's just double check. Go ahead, change to a pink. And let's see, B prime is right here. Well, B is there. So this is 1, 2, 3, 4 over and 3 up. So 4 over and 3 up. So when it goes counterclockwise 90, it goes 4 up and 3 over. So this point here is the new B prime, which is -3, 4. -3, 4. And that's exactly what we have over here. So 4 was our correct answer. Okay, question number 12. In the diagram below, circle O, the area of the shaded sector LOM is 2 pi centimeters squared. Now, we know this and this is the same and this. All 3 of these segments are radii. If that's the case, we also know this angle and this angle are the same because they are the 2 base angles of an isosceles triangle, with these 2 sides being the radius. It says if the length of NL is 6, N to L being 6, well, that's the entire diameter. So if that's 6, each of these must be 3. Next, it says, what is the measure of angle N? Well, okay, let's think about this. If we can find this angle right here, we can find the dot, the angle, because they're supplementary, and then we can find the base angles of the isosceles triangle by subtracting this dot angle from 180 and then dividing by 2. So let's take a look. We're given the area of this piece, so it seems like we need the area of the whole circle. So same formula, pi r squared, which equals pi times, oh, we're going to put 6. It's not 6, it's r, the radius of pi times 3 squared, which is 9 pi. Now that's the area of the entire thing. Now the fraction that is circled, that is shaded, the fraction of the circle that is shaded is the 2 pi. So 2 pi out of the 9 pi, so 2 pi out of 9 pi, those cancel, gives us 2/9 shaded. So if 2/9 are shaded, then this angle MLO is 2, so measure of angle MOL is 2/9 of 360. So if we multiply 2/9 of 360 degrees, this gives us, well, 360 divided by 9 is 40, and then times by 2 is 80. So 80 degrees is this angle right here. This is 80. So if this is 80, then there is a rule, which is the exterior angle of a triangle is equal to the sum of the 2 non-adjacent angles. So we do know the answer. The sum of those 2 is going to be 80, so one would have to be 40. But if you forget that rule, let's just go through the steps of what we know. This angle here is the supplement to 80, so 180 minus the 80 gives us an answer of 100, so this is 100 degrees. Now these 2 here, x and x, must be the same, so 2x plus 100 must equal 180, which is a sum of degrees in a triangle, minus the 100. So we end up with 2x equals 80. So if 2x equals 80, x must be 40 degrees. So x is where the measure of angle N is labeled right there. So the answer is number 3. Okay, this is 13. In the diagram below, ABC triangle is similar to DEF. So A to D, these angles are congruent, but the actual shapes are similar. So remember that similar shapes all have congruent angles. B is the same as E, and F and C are also congruent. Okie dokie, so it says if AB is 6 and AC is 8, well, those are both labeled, which statement will justify similarity by SAS? Well, SAS is that two sides are similar, not identical, so this doesn't have to be 6, just has to be a type of multiple of 6, and it could be a fraction as well, that's true. But that proportion of 6 to this side must be the same as, that ratio of 6 to this side must be the same as 8 to this side to create a proportion. So we got two sides, so we really need this angle to be congruent to this angle. So angle A and angle D must be congruent. Now if you look here, 3 and 4 are saying C and F. Well, C and F is not the angle between the two sides, so it can't be 3 and it can't be 4. So we're narrowing it down. The other thing that we need to know is that these angles must be in the same ratio as these angles here. Sorry, these sides here. So basically, if DE is 9, that means that 6 compares with 9 as, and then we've got 8 here comparing with 12 as 8 compares with 12. And let's see if this is true. Well, 6 over 9 simplifies. This becomes, well, 3 in here is 2, 3 in here is 3. This simplifies, 4 in there is 2, 4 in there is 3. So this is the information that will help us know that these two shapes are similar by SAS. Number 1 is our answer for 13. Okay, question 14. Question number 14. Here we are talking about a basketball and also a tennis ball. So if I draw it, here's the basketball, spherical, and here's the tennis ball, still spherical. Now in the first one we're told the diameter of the basketball, which is from one side all the way to the other through the center. The diameter of this thing is 9.5. So therefore the radius would be half that. So 9.5 divided by 2 is going to be 4.75. And the tennis ball diameter is 2.5. So the radius here is half that, 1.25. These are all inches. It says the volume of the basketball is about how many times greater than the volume of the tennis ball. Well, volume of basketball equals, the formulas on the formula sheet, 4/3 pi r cubed, which equals 4 over 3 pi times 4.75 cubed. Now, before I work that out, let's also find the volume of the tennis ball, which is 4/3 pi 1.25 cubed. Now I'm just getting ready to put these in my calculator. Be very careful with the graphing calculators that you use parentheses for 4 divided by 3, otherwise PEMDAS might work out in a way you don't expect. So I'm doing parentheses 4 divided by 3, close up the parentheses, times by pi times by 4.75 to the third power. That gives me an answer of 448.9 and change. So let me just write that in over here. 448.9. Okay, now the other one over here, let's just try and do that. Now, as I'm typing this, I'm wondering, do I need to leave this number stored in my memory or not, or is this good enough? Well, look at the answers. The answers here are all very, very different. 65 and 55 are close, but you know, rounding to 448.9 and not showing the hundredths place and the thousandths, I don't think it's going to make that big a difference. So let's continue. Volume of tennis ball. So we got 4/3, 4/3 times by pi, and then times by 1.25 to the third power. So this gives 8.18. So let's try this. 448.9 divided by 8.18. I get an answer of 54. So we're dividing because it says is about how many times greater. How many times greater is this basketball compared with this tennis ball? So how many of these could you fit in there? So when we do volume of the basketball divided by volume of the tennis ball, so 448.9 divided by 8.18, that gives us an answer of 54.9. 54.9 rounded to tenths. So this is the closest possible answer, number 3. Okay, here's 15. The endpoints of one side of a regular pentagon are, alright, and that gives you a few points. So a regular pentagon means that all sides are exactly the same. They are all congruent. And so these points might not look like they're in the right place, but it says the endpoints of one side. So let's just put negative, it's -1, -1, comma 4, and the other side is 2, 3. So it wants to know what the perimeter is. Well, if we find this distance, then because all of them should be the same, it's a regular shape after all, the perimeter is going to equal 5x, and it's 5 because this is a pentagon, and we know a pentagon has 5 sides, and it's being regular means that all sides are exactly the same. So to find x, I'm going to use the distance formula. So x equals, x is the distance between them, the square root of x2 minus x2 minus x1, so that's -1, plus, and then y2, 3 minus 4, and square it. So this becomes 3 squared inside, so that's going to be 9 plus 1. 3 minus 1 is 3 minus 4 is -1. Square it is going to be positive. So this gives us radical 10. Now it's very tempting to want to circle this one, but that's why you would make a loss. We need to remember that if each side is radical 10, what we need to do is multiply the radical 10 by 5 because there's 5 sides, and this gives us our answer, 5 radical 10, option number 2. Okay, in this question 16, in the diagram of the right triangle shown below, we got 14 AB and AC is 9. It says, what is the measure of angle A? So it wants to know what this is. So for angle A, these two things are the adjacent and also the hypotenuse. So when we're dealing with those, we've got to think so, ka, toa. We're thinking ka. We've got cos of angle X equals adjacent, which is 9, over hypotenuse, which is 14. So to find X, we do the inverse cos of 9 over 14. So I'm going to grab my calculator. We're doing second function cos, which gives us the inverse of the cos. 9 divided by 14. Close the parentheses. Press enter, and I get an answer of 49.99. But it does say to the nearest degree. So 49.99. We're doing nearest degree becomes 50. So that's our answer, number 3. this question, what are the coordinates of the center and length, the center and the length of the radius of a circle whose equation is this? Alrighty, so when we're given equations like this, we've got to try and make it look like this: x minus h squared plus y minus k squared equals r squared. So if we can find the center, the h comma k, we're good with that, and then the length of the radius, we've pretty much got that as well. So let's see how we can do this. In trying to make these two look alike, let's focus on the x's first. So I say I've got x squared plus 6x, so that could be x plus 3 squared. Now remember, this means x plus 3 times x plus 3. Now if we do this and we FOIL it, we get x squared, great. We get x times 3 is 3x, and plus another 3x, that's 6x, which we needed, so we needed both those. The only issue is that we also end up with this plus 9. So whatever we get here, after we distribute this, so plus 9 there, we just have to remember to add 9 to this side. That wasn't there before. So let's keep going, plus y. Now y is here, and it's also here as minus 4y. So how about y minus 2 squared? So we get y squared minus 2y minus 2y, and then plus 4. Well, if this gave us another plus 4, let's add it here, plus 4. So we've got to, if we create extra on the left, we've got to make extra on the right. Now, the only other thing, we dealt with each of these, but then we also have this 23, which also must stay on the right. So by simplifying this, let's change the color. By simplifying it, we end up with x plus 3 all squared plus y minus 2 all squared equals, now the sum of these things, that's 13 plus 23, the sum of them is going to equal 36. So our center, because this should say x minus h, our center must be negative 3, comma, and over here the k is the 2. So comma 2, that is your center. And then the only other thing that you needed was the length of the radius. Well, here is the r squared, so by square rooting you have the radius. And you could write radical 36, but that simplifies to 6. So here are your answers. Okay, 18. The coordinates of the vertices of RST are these, and then it says which type of triangle is RST. So let's just plot them. I'm going to grab the straight line tool. So let's plot some points. R is at -2, -3. Okay, S is at 8, 2. And then also T is at 4, 5. 4 is here. 5 is somewhere up here. So this is the triangle, and it wants to know in the questions what type of triangle is it. We should also call that third side by its name. This is T. Wants to know what type of triangle. Well, first of all, equiangular means that all angles are the same, meaning 60, 60, 60 to add up to 180, and that means that it must be equilateral, all sides the same, which is not happening here. Now we're left with 3 options. These 2 angles look like they're acute, but this third one, I'm not sure if it's 90 degrees or more or less. So let's test that out. To find out if this is 90 degrees, one thing that we can do is we can find the slope of TS, and we can compare it with the slope of RS. If they are negative reciprocal, then they are perpendicular, and therefore it's a 90-degree angle. So let's find this. The slope of TS. The rise, well, it goes down 3 and then across 4. So down 3 across 4. That's the slope. For RS, it goes from -2 all the way to 8. So that's the run. And it goes from -3 all the way up to 2. So -3 to 2 means slope of 5 over now -2 all the way to 8 is 10. So this is 1 over 2. Now I notice is that these are not the same slope and it's not the negative reciprocal. But maybe we should try this one because I sketched it. Maybe we should try and see if RT is perpendicular to TS. Okay, so one thing we should do here is to check the slope of RT to see if that's 90 degrees with TS. So let's figure this out. R to T, the rise is from -3 up to 5. -3 to 5 is +8. And then the run, well, it goes from right here, which is -2, all the way to 4. So that's over 6. Now if you simplify this, it becomes 4 over 3. And what I need you to do is compare this here with this here. What happened? Well, it was negated to give you that positive, and it's already negative, so negating a negative gives you a positive, and also it's turned upside down. So that means that these two are perpendicular, which means this must be 90. And if this is 90, it is a right triangle. Okay, question 19. Molly wishes to make a lawn ornament in the form of a solid sphere. So I'm going to stop reading, quickly sketch it. She wants to make something that's a sphere. Now we're also told that the clay being used to make the sphere weighs 0.075 pounds lbs per cubic inch. And it says if the sphere's radius is 4, r equals 4, what is the weight of the sphere to the nearest pound? Well, if this is how much it weighs per inch cube, let's find out how many inch cubes there are. So the volume of a sphere is 4/3 pi r cubed. So this is 4 over 3 times pi times 4 cubed. Now if I do all of this on a calculator, I get 4 divided by 3 pi and then 4 cubed. That gives me 268 and change. So we just write in 268 and 0.08 and change. Anyways, that's how many inches cubed. Now we know it weighs this much per inch cubed. So what I'm going to do is times it by 0.075. That should give us our answer for how many pounds. Times by 0.075. And that's 20.1 and change. 20.1 and a little change afterwards, 0.6. So anyways, to the nearest pound, that would have to be 20. Question number 20. The ratio of similarity between triangle BOY to GRL is 1 to 2. So I'm going to stop reading right there. BOY to GRL. So we've got to be a little careful. Which one's bigger? So 1 here to 2 here. So B to O, if that's 1, then G to R would be 2. So this is going to be double. So GRL. So if BO is x plus 3 and GR is 3x minus 1, that's a 3x minus 1, then what is the length of GR? Well, from our picture we know that x plus 3 has a relationship with 3x minus 1, and if this is double G to R, what we can do is times this first one by 2. and this is our equation to work on, and it's going to give you GR. So if we distribute, we get 2x plus 6 equals 3x minus 1. So when you add 1 and also minus 2x, let's see what happens here. We end up with 7 equals x. So if 7 is x and we are trying to find GR, we're going to plug this back in here. So GR equals 3 times 7 minus 1, which equals 20. So 20 is our answer for number 20. Okay, question 21 in the diagram below. Okay, DC, AB, DOB, and CB and AB are all chords. FDE is tangent, so let's time out there. That means that this is 90 degrees, this is 90 degrees. Also, as I start looking at this diagram, I can see that DOB is the diameter, and that creates C being inscribed, and so that has to be 90 as well. Any angles inscribed from a diameter is 90 degrees. Okay, anything else? I'm not sure. Okay, and also we're told the radius AO is drawn. Sam decides to apply the theorem to the diagram. An angle inscribed in a semicircle is a right angle. An angle inscribed, so that's what we just talked about. It says, which angle is Sam referring to? So he's referring to this one right here. And that is either DCB, or you could say BCD. And DCB is right here, so 3 is our answer. Okay, here we go. This is question number 22. The altitude drawn to hypotenuse AB of the right triangle ABC. So it says, which lengths would not produce an altitude of 6 radical 2, and it wants not produce. So let's see, if AD was 2 and DB was 36. So the ratio and the proportion goes 2 compares with 6 rad 2 as 6 rad 2 compares with 36. So 36 times 2 is 72, so we're just cross multiplying right now. And then these two multiplied, well, 6 6's are 36, and rad 2 times rad 2 is 2. So this in fact would be correct. But we are looking for which lengths would not produce. Well, number 1 would produce it. So let's try the next. If AD was 3 and AB, so that's here to here, A to B is 24. Well, if that first bit was 3, then this would have to be 21. So now the math becomes 3 compares with 6 rad 2 as 6 rad 2 compares with 21. Cross multiplying gives us 63 equals 36 times 2. Because when we do this, we get 36 6's, and then 2 comes from the rad 2 times rad 2. So this gives us 63 equals 72, which is not true. So that is our answer. 3 and 24, right? This is our answer. So labeling is really important because DB is not the 24. In fact, DB is 21 because we know AB is 24. Okay, so this question is a designer is creating necklaces. So a necklace goes around the neck, and it says perfectly circular. So this is a circular necklace, and we're told the radius is 10 centimeters. It says what's the largest number of necklaces that can be made from 1,000 centimeters of wire. So here's all the wire. Now if this is 1,000 centimeters, each one has a radius of 10, we're not going to do 1,000 divided by 10. But we need to first find out what is the circumference, the distance all the way around this thing. So circumference equals 2 pi r, where pi is in fact 10. So this equals 20 pi. That's the length of one. Now, if we have a total available length of wire that is 1,000, if if we divide this by 20 pi, that should give us our answer. So the zeros cancel. This 2 divides into 100 by 50. So we've got 50 over pi. So let's give that a shot. 50 divided by pi. And I get an answer of 15.9. 15.9. So equals 15.9. Now, you can't really make 0.9 of a necklace. So we go back to the question. It says, what is the largest number of necklaces? Well, think about it. Could she make 16? Well, she can't, because she's only got enough for 15.9. So therefore, if you can't make 0.9 necklaces, the only thing you can do is make the 15. So that would be our answer. Okay, this is the last question from part 1. It's question number 24. It says, in this triangle, TO are on SU and CU respectively. Segment OT is drawn such that angle C is congruent to OTU. So these two are the same. If TU is 4 and OU is 5 and OC is 7, it says what is the length of ST? So ST question mark, let's just call it X. Now one other thing to note is that this angle U is shared by the two triangles here. So let's try and clean this up. We've got the big triangle, which is U, let me make this a little clearer, U, S, C. Okay, now this distance at the bottom is going to be 12. It's the 7 plus a 5. And also this angle U here is the same as this angle U over here. But now we've got to be a little careful, because really this says T and this says O. But then that's going to be this angle up here, which isn't in the same place as a C. So one thing we've got to do, which will make our life easier, is turn this smaller triangle upside down. So that T becomes here, and this angle is the same as C, and that O becomes... But if we didn't turn this triangle upside down, switching the T and the O, if we didn't turn it upside down, then we'd get the wrong proportion. We wouldn't have matching corresponding sides. So let's take a look. Want to know what ST is? Now ST is a part of SU. So one thing that we know is that this 5 here compares with this side up here. Let's just call it Y. And this side here, 4, compares with this here. Let's call it, well, it's labeled as 12. So therefore, to go from 4 to 12, so 4 over 12 equals 5 over Y. By cross multiplying, we know that 4Y equals 60. Divide both by 4. We then get that Y equals 15. So if 15 is everything, this whole thing is 15. This whole thing here would be 15. So that would mean that X equals that 15 minus the 4, the TU, which we equal 11. So our answer is number 3, 11. Okay, so this is now part 2 of the Regents test. This is where question 25 starts off the section. So let's take a quick look. We are told that this triangle called ABC is graphed on the set of axes below. Graph and label A prime, B prime, C prime, the image of the original, after a reflection over the line X equals 1. So a lot of students get confused when X equals 1 or Y equals 1, how to actually draw this line. Well, the line X equals 1 goes through where X is 1. So if this is where X is 1, the line must go through this point. So that's the first thing. X is always 1 across this entire thing. So we should label it, put the arrows, and this is X equals 1. So next step, we move every point across the line of symmetry. So B is 1 point away, it becomes B prime, 1 point away on the other side. C is 1 point away, it becomes 1 point away on the other side. A is 1, 2, 3, 4 jumps to the mirror. So 4 jumps again, 1, 2, 3, 4. And A prime is here. Just grab a straight edge, join them all up. And that is our image. A prime, B prime, C prime. So that's question number 25, the first open response question that we've had. Okay, 26. So in this question, we are asked to determine and state the measure of AOB. AOB is what we're looking for. So let's label it A to O to B. This is what we need. Now we are told that COB, so diameter BC, so therefore this is a radius, this is a radius, and also this is a radius. It goes from the center to the edge. Now if you look carefully, this triangle ABO is in fact an isosceles, so these two are congruent because they're both the base angles. We're also told that DC is parallel, so DC is right here. D to C is parallel to A to B. So if this is parallel to this, we also know that this angle DCO must also be the same as OBA because they are alternate interior angles. So we're given more information. We just labeled a bunch already. So we're told that BCD, B to C to D, which was that last angle we were talking about, is 30 degrees. So if this is 30, this must be 30, and if that's 30, this must be 30. Let's just call this angle X. So as you see, if we label everything we know that's given in the question, it makes it very, very easy to solve these problems, because once we're given a little more, we fill it in and the whole picture becomes clear. So in this triangle, we've got 230 degrees in X, so therefore 30 plus X, those three angles must add up to 180. So if these two give you 60, so therefore if we take the 180, subtract the 60, gives us 120 degrees, so the measure of angle AOB equals 120 degrees. Notice how I rewrote it with the AOB, because that's what we're asked for. We're not asked for X, so you should always try and restate it with what they were asking for. Okay, so question number 27 says a directed line segment PT has endpoints whose coordinates are, and then we're given a couple of points. Okay, so let's take a look. So I just brought up the axes. So let's plot -2, 1, -2, 1. Just need to bring this over here. -2, 1 is right here. So this is P, and T is at 4, 7. So 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7. That's what T is. I'm going to write this down, 4, 7, and this is -2, 1. It says determine the coordinates of J that divides the segment into the ratio of 2 to 1. So the trick to do this is when you're told that it's going to be a 2 to 1 and it's dividing the segment P to T, we've got to think J divides this segment J, and if it's dividing by this ratio 2 to 1, we've got to think, where's it closer? Is it closer to P or to T? Well, what we've got to do is we've got to separate this segment into 3 pieces, because the sum of these parts is 3. There's 3 total parts, and if we're able to do that, then we go 2 of these parts from P to here, and that's going to be J. So J is closer to T. So knowing that, let's try and come up with our first step. Well, I'm going to draw the line, because it does talk about line segment PT. Now the trick that I use is, once I know it's 3 parts, what I do, I try and split this segment into steps of 3 steps. So if I go across and up, across and up, across and up, that's 3 steps right here. Or you could see that it's kind of like 3 right triangles that are living along here. And final trick is just really to go up the number of steps that we need away from P. So we're going to go up 2. This is 1. This is 2. And that would be the third to take us to the top. So P is 2 of these steps up. So that's where P is going to go. And you can read off the points. It's right here and across here. So it's 2, 1, 2, 3, 4, 5, 2, 5. So point P is at 2, 5, and that's our work. Now there's other ways to do this involving the distance formula, but this is way easier. And we've shown some work, and we've used the axes, which should also explain part of our work. So that was question number 27. Alright, question 28. So this says that A prime, B prime, C prime is the image of ABC after a sequence of transformations. It says, is ABC prime congruent to ABC? Use the properties of a rigid motion to explain your answers. Well, it does talk about a sequence of transformations, so let's think what might have happened. So I'm thinking maybe we could have reflected somehow. So I'm seeing that A is here and B is here, whereas on the other side it's kind of flipped. B is now on the outer side. So that's something that we should think about. Well, let's think. Let's think, well, if I move this shape, I'm just eyeballing right now, but if I move it so that C is down here, and that B also moves down, then this first one is going to be a translation. So let's think about this. And we're asked to say if it's congruent, and it looks congruent. So it says use the properties of rigid motion to explain your answer. So in the sequence, just write this in the sequence of transformations, the first move could be a translation. How many units down? 1, 2, 3. 3 units down. Then after it's here, we need to reflect it over the y-axis. Then a reflection over the y-axis. And I know that so far I've just really been focusing on point D, but I could focus on any of these points. It would definitely map it onto itself. So now we would say that triangle ABC maps onto triangle A prime, B prime, C prime, and because translations and reflections are both rigid motions, we know the result proves congruent triangles. That's pretty much enough. It just wants you to mention a sequence of transformations that are rigid motions. So you want to stay away from talking about dilations, and you want to make sure the sequence of transformations that you talk about are as precise as possible and are accurately getting the shape ABC onto A prime, B prime, C prime. Okay, question 29. All right, in this question, carpenter leads a ladder against the house to reach the bottom of a window 30 feet above the ground. That's all shown. The ladder makes a 70-degree angle, which is shown to the nearest foot. Determine and state the length of the ladder. So this is really X. There's the ladder. This 30 could be moved over here. Same. So we've got an angle here, 70. We've got the opposite side and we've got the hypotenuse. So opposite and hypotenuse is part of sine. So basically sine of the angle, sine 70, equals opposite all over hypotenuse. And if you are trying to find out the x, what you can do here, because it's a denominator, you can times by x and then divide by sine 70, which effectively just switches this. So x equals 30 all over sine 70. So in this case, x would equal, and it does want the nearest foot, so I'm going to get that ready. So I'm going to grab a calculator, do 30 divided by sine 70. 30 divide sine 70, and I get 31.9. So to the nearest foot is 32. And what I might do is I might write 31.9 here, but then show that I've rounded it here. And this is my final answer. You can also say the height of the ladder is 32 feet as well. That would work. Okay, so that was 29. Okay, question 30. During an experiment, the same type of bacteria grow in 2 petri dishes. Petri dish A has a diameter of 51 and has approximately 40,000 bacteria. Petri dish B has a diameter of 75 and has approximately 72,000 bacteria. So this is obviously more and this is obviously less, but is this more for every piece of area, or the fact that this has a bigger diameter, does it mean that there's much more room available in here? So this is all to do with density. And it says determine in state which petri dish has the greater population density of bacteria at the end of the first hour. So to do that, we need to take the number of bacteria, so number of bacteria, and divide it by the area of each. So we do this for A and we do this for B. So in the case of A, the number of bacteria is 40,000 divided by the area. Now the area of this equals pi r squared, which equals pi times by 25.5 squared. And this one over here, area equals pi r squared, which equals pi times by 36. What am I doing? Not 36,000. I've got to take 1/2 of the 75. So 1/2 of 75 is 37.5. 37.5 squared. So let's figure out both of these numbers. And so for A, I've got a density of 40,000, so must do this. Pi times 25.5 squared equals 2042. So I'm going to take this and divide by 2042.8. And then for the B, I'm going to take the 72,000 and divide by pi. Actually, let's find out what the denominator is. So it's pi times by 37.5 squared, and that is 4417.9.86 really. So when I do 40,000 divided by 2042.8, I get a density of 19.58, or let's just say 19.6. And this is bacteria per milliliter squared, so bacteria per millimeter squared. So that's for A. And then for B, let's do this. I've got 72,000 divided by 4417.9, and that gives me 16.3. Is 297, so 0.3 bacteria per millimeter squared. So it says determine in state which petri dish has the greater population density. So dish A has the greater population density, and the evidence is right up here. It has 19.6 bacteria per millimeter squared compared with 16.3 bacteria per millimeter squared. So that's question number 30. Here's 31. So in this question, line L is mapped onto line M by a dilation centered at the origin with a scale factor of 2. The equation for line L is this. Well, first of all, whenever I see this, I always want to rearrange it to look like y equals mx plus b. So let's try that. So if I add y to both sides, I end up with y plus 4 equals 3x. If I minus the 4, I end up with y equals 3x minus 4. So I could do a really quick sketch of this. Negative 4 is here. And then I know the slope is 3, so that means for every 1 across, I go up 3. For every 1 across, I go up 3. And so the line would kind of look like this. Now it's say determine it and state the equation for line M. Well, line L is mapped onto line M. So L is somewhere else and it's mapped onto line M. So this is L, so I'm going to label it. And they want to state the equation for line M. Well, let's just see a couple of points. There's a few different ways to do this, but 2 points that we've got here are when x is 0, y is negative 4. And then as we kept doing this, as you go across 1 and up 3, we get this other point here, which is 1 comma negative 1. So these 2 points are living on this line. Even though we've got the equation of a line, which I can write it, but here it is. It's y equals 3x minus 4. And this is line L. And these are 2 points. And then it says it's dilated by a scale factor of 2. So let's think what that does to this. If the scale factor is 2, we take both of these points and we times it by 2. So this becomes 0 comma negative 8. And this point up here times by 2 becomes 2 negative 2. So using that information and y equals mx plus b to find the new line, line M, let's first find the slope. So the slope equals the change in y. So it goes from negative 2 minus negative 8 all over so that's the rise, all over the change in x, which is 2 minus 0. So the slope is, this can become plus because it's minus negative, so it's plus. It becomes 4, no, it becomes 6. Negative 2 plus 8 is 6, divided by 2 is 3. So we now know the slope is 3x plus b. Let's plug in one of these points. Let's plug in 0, negative 8. So when x is 0, y is negative 8. So therefore 3 zeros are 0. So therefore b equals negative 8. And we just plug back in. So I'm coming over here. I'm taking this b. I'm taking this m. So the equation for line M equals 3x minus 8. That is my equation for line M. And the other one, the equation was 3x minus 4. Okay, so this is part 3, the first question in this section. It's question number 32. So as we get closer to the end of the test, the questions are expecting more work from us, but they're worth 4 and then later on 6 points per question. It says the aspect ratio, the ratio of screen size width to height of a rectangular flat screen TV is 16:9. So let's quickly draw this. So this would be 16 parts, this would be 9 parts. This gives us a 16:9 ratio. it says the length of the diagonal across the screen. So let's change up this color. Length of the diagonal across the screen of this flat television, and it actually wants us to determine and state to the nearest inch what this diagonal screen size is, and it tells us with if this screen height is actually 20.6. So keep in mind they've told us that it's a 16:9 ratio, but they've now told us the height is 20.6 in real life inches. So we've basically got the little model, which is just a 16:9 ratio, and then you've got the real full size TV where this is 20.6, but they're trying to find this thing, they're trying to find the X here. So one thing we could do is try and find this here, and then we can make a proportion. So let's just call this Y. Now if this is 9, this is also 9, and hopefully you see that this is this thing here is a right triangle. So 9 squared plus 16 squared must equal Y squared. So 9 squared is your 81, 16 squared is your 256, and that has to equal Y squared. So when you add these two together, you get 337, and that equals Y squared. So when you square root both sides, right, so that gives you a Y value of 18.36. So Y equals 18.36. Now, we've got to be a little careful. We did round this. The number does go on. But anyway, if this thing here is 18.36, we can now set up a proportion, because we know that 9 compares with 20.6 as the 18.36 compares with X. 18.36 compares with X. Now we can cross multiply to solve this, but also instead of finding Y here, we could have done 19 over 20.6 equals 9 over 20.6 equals 16 over the length here, and then we could have used these two numbers in a right triangle here, but we're going to get the same answer. So basically by cross multiplying, we've got 9x equals 20.6 times by 18.36. Now I'm actually going to leave the full number on my calculator in there and just do times that answer by 20.6, and then I'm going to divide by the 9 on my calculator, and that's when I get a final answer of 42.01. so it says to the nearest inch, so therefore X would have to equal 42 inches, and I probably would make a statement, the diagonal of the TV would be 42 inches long. And so that's question 32. Okay, so question number 33. We're given a theorem: the sum of the measures of the interior angles of a triangle is 180 degrees, and it wants us to complete this proof. So this angle 1, angle 2, angle 3 all make 180. That's what we're trying to prove right here, and we're just given a triangle. So they start us off with a 2-column T-chart for statement reasons. The first one is triangle ABC, and that is given. The next statement is that through point C, now point C is here, through point C, draw DCE parallel to AB. And the reason why they're making this statement is that they can make comments about alternate interior angles and how these angles line up when there's two parallels cut by a transversal, or in this case two transversals. So they've said through point C, draw DCE line parallel to AB, and the reason for that is that to a given line there's only one parallel line that can be drawn through a point not on the line. So let's just think how we can write that. To a given line, we would say there is only one parallel line to a given line intersecting with a point. With a point off the line. Alright, so that's just a commentary for a reason for the first one. So we've drawn this line, that's why it's dotted, and this is the rule. There's only one line that can be drawn. That's a fact. Next, the measurement of angle 1 equals the measurement, so angle 1 is here, equals the measurement of angle ACD, A to C to D, so that's here. 1 equals ACD, and the reason for that is that they are alternate interior angles are congruent. So let me write that. Alternate interior angles are congruent. And so that's what we talked about before. Two parallel lines. These here are parallel, this whole thing. This is like your transversal. And so angle 1 equals this angle up here. Next, and also measure of angle 3, which is right here, is congruent to measure of BCE right here. So that's all part of the same reason, number 3. Next it says the measure of angle ACD, A to C to D, plus the measure of angle 2, plus the measure of angle BCE equals 180 degrees. And the reason for that is because if these are congruent pieces and they all effectively match up to 3 parts of a triangle, whereas ACD, A to C to D, is angle 1. This is measure of BCE, B to C to E, is effectively the measure of angle 3. The reason in this case is the sum of angles on one side of a line is equal to 180. So sum of angles forming a line is 180 degrees. And so here you can see how we've gone from this line down to what I have up there by dropping in the measure of angle 1 for the measure of angle ACD and dropping in the measure of angle 3 for the measure of angle BCE. And the reason that we can describe here, just like I've said, drop them in, is the substitution property. And that's what we're asked to prove. So we've just done it. So that completes question 33. Question 34. Gotta be a little careful here. This is a construction. So triangle XYZ is shown below. Here it is. Using a compass and a straight edge on the line below, construct and label ABC such that ABC is congruent. So we need a congruent triangle to this on this line. Okay. Based on your construction, state the theorem that justifies why triangle ABC is congruent to triangle XYZ. So first of all, we got point Y here. Let's just put a dot over here, and instead of calling it Y, let's call it B, because Y is in the middle of this list and so is B. So B should be the same place as Y. Next, now this is a little tricky, but this is what we got to do. We put our point on Y and we open it up as far as X. Then we bring our compass back, we put the point on B, and then we do not close the compass. You just make the same arc that was made over here where X is, but you put it right here. Now I'm going to label this. This X is the first letter up here, so it's going to match with A. So this point, the intersection of the line and the arc, is point A. Now the next bit, I'm going to change this to orange. I'm going to go back to my original point Y, put the point of the compass here and open up the compass so it's the same size, the same length as YZ. And then I'm going to come back to point B, put the point, and I'm going to do the same little mark for point Z here, except I'm going to go further. I'm going to use my compass to make a big arc like this. And everything here is equidistant from B, just like the distance from Y to Z. That's equidistant to everything on this orange arc to B. Next, I'm going to grab blue. Now I'm going to put my point of the compass on X, and I'm going to open this up to where Z is. And again, I'm going to mimic this action by putting the point on A, and then I'm keeping the compass the same distance opened, and I'm going to draw my arc just so that it intersects with the orange. I don't need to go any further. I found the point I need, which is right here, the intersection of these two arcs. So finally, I'm going to connect up the 3 points that make the triangle with a straight edge. It must be a straight edge. And now I've got two congruent triangles, and so I can make that statement that, and I've got to label it as well. So I've got A and B. I must label this as C, otherwise I'm going to lose a point. And then finally, I'm going to say that triangle ABC is congruent to triangle XYZ, and it wants to know, state the theorem. So the theorem, why these two triangles are exactly the same, to do with using the compass, is that all the distances are exactly the same. When I open up the compass for the distance XY and move it for AB, it's the same distance. So therefore in this case, I've got this distance was the same as this one, this distance was the same as this, and also this distance was the same as this distance here. So therefore the theorem is by side, side, side for congruency. Now there is another way that this could have been done. I could have opened up the compass for this side and matched it. I could have opened up the compass. I then could have actually copied an angle here and copied this angle using a different construction process, and then copied this distance here, and that would have also worked by side, angle, side. But in this case, I thought this was a little easier, so side, side, side for congruency does the job. Okay, so this is question 35, which is the first of the 6-point questions. This is asking me for a proof. You could do flowchart proof, you could do a paragraph proof. Probably the easiest of all, just to get as many points as possible, is going to be the 2-column proof with the statement and the reason. So I'm going to stick with that just to make sure I get all the points. I'm just going to be a little careful here, so I'm going to write statement. I'm going to write reason. Also going to number every statement, so I got to get in the habit of that. So the first thing that we've got to do is look at what we're trying to prove. We're trying to prove that triangle A to N to W is congruent to DRE. So this triangle here and this triangle here, we're trying to prove that those two triangles are congruent. And also we're trying to prove that quadrilateral AWDE is a parallelogram. AWDE, A to W to DE. We're trying to prove that this shape here is a parallelogram. So there's two proofs wrapped up in here. The first thing that we're given is all of this stuff. So I'm going to write it just because we're given that. So parallelogram, I'm going to shorten it, parallelogram ANDR with line segment AW and DE bisecting NWD and REA at W and E. Reason? Given. Okay, so now we've been given that, you should always try to make congruency statements after a given. So because we're told that this is a parallelogram ANDR, so A to N to D to R, the entire thing, we now know that certain segments are congruent. Segment AE is congruent to segment RE, so A to E and R to E, and that's because we know that DE is bisecting. And also we know that, let's just see, not only do we know that AE and RE are congruent, but we also know DW and NW. DW segment and NW segment are congruent. And we can just put for this number 2 definition of bisects. Something else that we can say right now is that AN, which is the top segment up here, is congruent to RD. And also we can say that AR, this one over here, is congruent to ND. And the reason for that is opposite sides of parallelogram are congruent. Now our fourth statement could be about segment RE and NW. So RE and NW, those two are congruent. If you look, RE, which is right here, and NW are congruent. And the reason for that is that if RE is congruent to AE, and if NW is congruent to WD, then those are half segments of congruent segments. So that would effectively be our reason. So halves of congruent segments are congruent. So that would be our reason. Number 5, we can make a point about angle R being congruent to angle N. And the reason for that is opposite angles in a parallelogram are congruent. Opposite angles in a parallelogram are congruent. And so that's this here equals this here. Now remember that we're trying to prove that the first proof is that triangle ANW is congruent to triangle DRE. So already I'm seeing side, angle, side, side, angle, side. So maybe it's time to make that statement of that proof. So we can just copy it exactly. So number 6, triangle ANW is congruent to triangle DRE, and that would be by side, angle, side. Next, number 7, so we're going to keep this going because it also wants us to prove that this shape here is in fact a parallelogram. AW, A to W to D to E is a parallelogram. So the next bit would be ED and WA. So I'm going to say segment ED is congruent to segment WA, and the reason for that is that after we've proven these two triangles are congruent, each piece that's corresponding is congruent. So that would be corresponding parts of congruent triangles are congruent, CPCTC. So all of a sudden we know this side is congruent to this side. And obviously as labeled in the diagram, we know AE and WD are also congruent. So we should write that, AE and WD. So AE is congruent to WD. And again, it's to do with the halves of congruent segments are congruent. So halves of congruent segments are congruent. And finally, number 9, we would say the quadrilateral AWDE is a parallelogram. That's what it wanted us to prove over here. But now we need a really good reason. So the reason is to do with the definition of a parallelogram. And so we can say if opposite sides of a quadrilateral are congruent, so AE and DW, and also ED and AW. So really, if opposite sides, really, I should really use the word both pairs of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So sorry, it's a little messy. I tried to squeeze all of that in, but we did just get there in the 9 steps. So that was number 35. Okay, last question. Question number 36. All right, a lot of words and a picture as well. So Kathy wants to determine the height of the flagpole. So when I look at this picture, I see the flagpole top is here, bottom's here. If I look across, this 1.7 is interesting. So I know this bottom bit, 1.7, goes to here, and then let's say the top of this is x. So the height of the flagpole is going to be x. Can't forget this, x plus the 1.7. So if I find x, add it with 1.7. So she uses a survey instrument to measure the angle of elevation to the top of the flagpole. So that's this instrument here. This is the angle of elevation here. This is the angle of elevation there. Says she determines it to be 34.9, so that's listed there. She walks 8 meters closer, so that's here. This is 8, and determines the angle of elevation to be 52.8. Great. At each measurement, the survey instrument is 1.7 above the ground. Determine and state to the nearest tenth of a meter the height of the flagpole. All right, so a couple of ways to go about this. If I split up these triangles, one thing I see is that I've got a very nice right triangle here where this is 52.8 and this is x. Now I don't know anything else at the moment. The other triangle I see is right here. Now this isn't a right triangle, but it could be useful to us. Let me just clean this up a little. This triangle could be useful to us. Oh my gosh, terrible triangles. Got to use this straight line tool a little more. Okay, so this second triangle looks like this. Now, we could also have looked at the big right triangle ending with 34.9, going all the way over here. But there's something about this, because I know that this is 8. Now, I don't know this side, but I know that this side, let's call it y, matches with this side. And if I can somehow find what y is, if I can find what y is and plug it in here, then I can use SOHCAHTOA, the trig ratios, to find x. Once I've got x, all I need to do is add it to 1.7 and I'm good. So, if I look carefully at this, what else do I know? Well, I know that 52.8 is here, and on the other side here, this must be 180 minus the 52.8. So that's going to give me this other angle on the inside. So clear 180 minus 52.8. That gives me an answer of 127.2. So let me fill that in. 127.2 degrees. Might be useful. 0.2 degrees. 127.2 degrees. So I've got 2 angles here, so I guess I could find this third angle here. if I do 127.2 and then add the 34.9, so sometimes when you're not sure how to do it, you just find stuff out. Add 34.9 and maybe it's going to help you. So that gives me 162.1. So I've got to subtract that from the 180. 162.1 80 minus 162.1. So that gives me 17.9. So 17.9 degrees. So I got all these three angles. So to find y, it's looking like maybe I've got two pairs. I've got this y matches with this, and I've got this 17.9 matches with the 8. Alright, so one thing we've got to do is be very careful how we set this up. It does look like the sine rule, so we've got to be very careful. So y is what we need, which is a side, all over sine of the angle opposite, which is the 34.9, and that has to equal 8, which is a side, all over the sine of 17.9. So when we multiply both by 34.9, sine 34.9 cancels here, we end up with just y equals 8. Got to make sure we multiply both sides by the sine 34.9, and then on this side we still have the sine 17.9 as well. So I'm going to grab my calculator and I'm going to do 8 sine 34.9 gives me 4.577. I'm going to divide that by sine 17.9, and that gives me a distance of 14.89. Now this is rounded, but so far that's just this distance here. So 14.89. And change, so I'm going to even write it here. 14.89. Now once the height of the flagpole, so I'm dealing with x, and then I can't forget I've got to add the 1.7 as well. So in this triangle, we got the 52.8, we got the opposite, and we now know the hypotenuse. So when you're dealing with the opposite and the hypotenuse, you're dealing with sine. So sine of 52.8, sine 52.8 equals opposite, which is x, all over hypotenuse, which is 14.89. Now I've got the whole number on my calculator screen, 14.89203981. So what I really want to do to get x on its own is times by 14.89. These have cancelled here. So x equals 14.89, no, 14 point, yep, it is a 9, that is a 9. 14.89 sine 52.8, and then whatever I get, I must add the 1.7, and that should give me the height. And the height is measured in meters. I'm just going to write height of flagpole. But my answer is going to go right here. So we change color to green. Type all of this in my calculator. So I got the 14.89 and change times by sine 52.8. Press enter. And then just add the 1.7. So it gives me 13.56. Now it does say to the nearest tenth of a meter. So 13.56 becomes 13.6 meters. And that is my final answer for question number 36 and the conclusion of this test.